look at the formula here, ladies and gentlemen. And hang on a second. I need to get this into a place where I can write it. So let's do this. All right. Come into here. All right. So in the compound H2O, compounds make things just slightly different, ladies and gentlemen. First of all, what elements are involved in H2O, Jonathan? What are the elements involved? Okay, thank you. I actually just wanted the elements, but you gave me the amount too. So we have the element hydrogen and we have the element oxygen. How many hydrogens again, Jonathan? There are two of them. There are two of them. How many oxygens? One. Now, once we know the element and we know how many of them there are, we need one other thing. We need the mass off of the periodic table. So, Adeline, on the periodic table, what is the mass for each hydrogen atom? And again, ladies and gentlemen, depending on the periodic table you use, the numbers might vary slightly. I have seen 1.008. I have seen 1.0079. They are close enough. We can use whichever one is on your periodic table. All right. So now I need the mass of oxygen off of the periodic table. So Leslie, on your periodic table, what is the mass of oxygen? Or 15.999. Fine. Excellent. Perfect. Good. So now, ladies and gentlemen, to find a molar mass of this compound, we not only need to add up their masses, but we need to account for the fact that there are two hydrogens here to every one oxygen. So we are going to take these two hydrogens times this mass, and we are going to figure out what the total is here. So we're going to take 2 times 1.008. What is the answer for 2 times 1.008? Good, 2.016. What about 1 times 15.999? Yeah, that doesn't change because it's 1, it's 15.999. Now, ladies and gentlemen, what we are going to do is we are going to add these two numbers together. We are going to add these two numbers together to give us 18.015. Now, when we have 18.015 grams of water, we will have 1 mole of water. So this is how you find what is called the molar mass. So in this container right here, ladies and gentlemen, I have 18.015 grams of water. Okay? Now, again, if you have a larger mass of water, you're going to have more moles of water. So if we had twice this mass, instead of 1 mole, we would have 2. If we had 10 times this mass, we would have 10 moles. Everything can be scaled up. Everything could be scaled down. But 1 mole of water has a mass of 18.015. Questions? Okay. So in these containers, ladies and gentlemen, right here, I have sucrose. This is the sugar that you have at home that you will put into coffee, tea, Kool-Aid, whatever you use sugar for at home. This is the stuff that we're going to use. Now, obviously, it is a much larger particle than water because there's a lot more of it in here than there is in here. Well, that is because each one of these particles contains 12 carbons, 22 hydrogens, and 11 oxygens. So now, ladies and gentlemen, what we are going to do is in this table down here, we are going to list the elements. So they are carbon, they are hydrogen, and they are oxygen. And then next to it, we will list how many of each. How many carbons are in this formula right here, Virginia? How many carbons? How many carbons are in this formula right here? So what number is after the C? That tells you how many there are. All right. How many hydrogens are here, Brianna? There are 22. And how many oxygens are here, Calvin? There are 11. Now we go to the periodic table, ladies and gentlemen. Esmeralda, what is the mass of every carbon atom on the periodic table? 12.01. Is it 1? Okay, thank you. All right, what is the mass of every hydrogen atom on the periodic table? Adeline, sorry, my bad, Adeline. 1.008. By the way, it's the same as it was up here. That's never going to change. Okay? Now, what is the mass of each oxygen atom here? Susan? Now, this is a little bit tougher math because we're going to have to take this 12 here times this 12.011. So somebody take 12 times 12.011 and tell me what we get. 144.0132?
No, 13200.
Thank you. Sorry, I have 1 0 in there that I shouldn't. Thank you. Now, someone please take 22 times 1.008.
22.176.
And someone take 11 times 15.999. 0.98? All right. Now, take and add these three numbers together here, ladies and gentlemen. Again, with your calculator, take and add these three numbers together.
342.297.
Okay. So, if you go home today and you measure out 342.297 grams of sugar that you have sitting wherever you have it at home and put it in a container, you will have 1 mole of sugar. You will have 6.02 times 10 to the 23rd particles of sugar in that container.
Is that how much is in there?
That is how much is in there. Questions? So when we are doing a formula, we need to know two things. We need to know how many of each atom are in the formula. That comes from the formula right here. I will have to give you that. And then we need to know the mass of one of each of those atoms. That we get off the periodic table. So the formula gives us how many of each. The periodic table gives us the mass of each. We multiply them together. And then we add up all of the different things that are involved. Questions? All right, try to do these two real quick, ladies and gentlemen.
Can you stop staring? Well, I can't wait, bro. You need to smoke there? So I'm gonna walk my little team, bro. No, I'm just gonna go Okay. So I don't like football. For real. Why is we watching other men play sports?
You should. They said it. Just kidding. Just kidding.
Okay, well, what are the elements involved in this compound? Okay.
All right. I should have done this with you, ladies and gentlemen. Let's stop for just a second here because, again, I should have done this example with you because it's been a while since we have done this. So hold on one second here, please. All right. This is the one that we're going to do here, ladies and gentlemen. All right. So, first of all, what elements are involved in this compound? Go ahead, Osmar.
Zinc and nitrogen oxide.
Zinc, nitrogen, and oxygen. Okay? Now, how many zinc are there? Sorry, hold on. Thank you, Genesis. How many zinc are there? One. Now, there are some nitrogen here, right? In this compound, NO3, how many nitrogens are here?
3.
No.
2. 1.
There's 6.
Slow down.
There's 1.
Slow down. Slow down.
There's 1.
In the compound here, there is no number by the end, so what does that mean? 1. However, the 2 outside here, ladies and gentlemen, will multiply that number times 2, and it will do it for both of the things inside. So I agree there is 1 N in NO3, but the 2 outside means there are how many total? 2. And for the oxygen, there are how many? 6. The number outside multiplies by the inside. Okay? Listen, and I will tell you, when you look at the formula, okay? When we look at this formula, there is a 2 outside of the parentheses here. That 2 means multiply everything inside the parentheses times 2. So there is only 1 nitrogen here times that 2 on the outside. That's how we get the 2 here. There are 3 oxygens in here times the 2 on the outside gives me the 6 oxygens there. So now, fill in your masses. Do your calculation here and here. The next one, ladies and gentlemen, does not have parentheses. So you do not need to worry about this part. You just need to write down the elements that are there, find their masses, and do your calculation. Go to work, please.
Y'all can't wait for Friday, bro.
Yes, team. Didn't y'all win like last time team was?
I think we're in second place.
One thing about Black FC,
Like my third time.
Mr. Brent.
That doesn't look like anything we're doing right now, does it? I understand, but are you doing this? How can you be doing it if you're not even on the right side?
I was watching you do it.
And what are you supposed to be doing now?
Doing the math.
So do those on your worksheet, in your notes.
Zinc is.
Again, do it in your notes.
Mr. Brent, what you think about Flax FC? What you mean about that?
He's a coach.
I don't think you're getting much done. That's what I think about
What do you
that.
think about Flax FC?
I'll tell you what, you get this done and I'll give you my opinion on it.
Bro, what? That's like asking someone. I don't even sense.
What do we say?
All you asking for is opinion on fuck with it. See if you don't know fuck with it. If he just wants you to do the work for free.
So I'm not doing it, but you're a genius. Thank you. I thought it was on the game.
I wonder what group leader is.
Because you kind of have a really small, like, I can't even see the
Group leader. What do you think about Black FC?
Did it make sense the first
You don't fuck with your team, bro.
Hey,
Oh, sorry. You don't like your team.
Really? Really? They only put 25
So what you're doing, you're doing correct.
But y'all went 2 and 35 last year.
Well,
Y'all lose every game. Y'all would lose every game.
one card is first.
Look, bro. Bro, I feel like they hyped it up too much. It was like you post every week, every day. You post on it.
Yeah. Yeah.
They're laughing.
That's a lot.
We're lost. We didn't want you. We didn't want you. Come on.
There's like 50 players on the roster.
Perfect.
We're really getting in trouble.
And all them paid.
I don't know.
All them $15. Is the owner doing something? Pyramid scheme.
Hey, you wanna keep sitting here?
Yeah.
Get to work.
I am.
No, you're not.
Let's try different.
You haven't done the one yet. You didn't do the last one. What?
I don't feel it, no.
Why?
Because I don't need the notes.
Oh my god. Got germs.
I'll do you.
Not even joking.
I don't think they use that.
I'll look if you're lying, bro. I'm actually no dead. I don't want to be on the legs.
What's that?
Because I don't want to be like this fading to the
We're on slide number, I think it's 12 or
Use your face.
so we're in unit 4, yes.
I didn't see the
Oh, he's gonna act like he's
What's that?
Nah, I'd rather
We're in
be
the,
dead.
in the notes, yes.
So I can't hear no crazy shit, bro.
So I can't hear like this.
So I can't hear no bombs.
Luis, go sit in a different area away from those boys. Because you just swore, and I'm sick of you sitting by him and doing nothing but talking.
I didn't swear.
You used the word shit.
I didn't.
Dude, I heard it.
I
I
said
didn't.
so I can't hear no
Dude,
bombs.
go sit somewhere else now.
For what?
Because I asked you to.
I don't want to.
Then you can go down to the office and explain it to the principals.
Bro.
Those are your two choices.
Why do I gotta move?
Because I asked you to.
I'm doing my work. I
Dude,
can answer the question.
we're done. You either move or you get out. Those are your two choices.
Why?
Because I've given you two choices. Pick one.
I'll move right there.
That's fine, but your next move, if you're still talking there, is out of the room. So choose wisely. All right. So, here we go. What's the mass of every zinc in here, Virginia? What is the mass of every zinc? 65.38. What is the mass of every nitrogen here, Esmeralda? What is the mass of every nitrogen? And what is the mass of every oxygen here, Leslie? 0.999. So when we take this times 1, ladies and gentlemen, that stays 65.38. When we take this times 2, that is 014. And finally, ladies and gentlemen, when we take this, this is 95.994. Now we add them together. What do we get for a total? Someone please. That is what you should have gotten for this one. Are there any questions? All right. So now we have another one here for lithium carbonate. So the elements that involve, ladies and gentlemen, are lithium, carbon, and oxygen. How many lithium are in this compound? How many lithiums are in here, Genesis? 2. How many carbons, Christian? 1. How many oxygens, Jonathan?
3.
Faustino, what is the mass of every lithium atom?
6.94.
What is the mass of every carbon atom in here, Jordan?
12.011.
And what is the mass of every oxygen atom in here, Yomali? So when we take 6.94 times 1, ladies and gentlemen, we end up with 13.98. When we take 12.011 times 1, we end up with 12.011. 88, sorry, my bad. 13.88. Let me fix that. Thank you.
Yep.
Bless you. And when we take 3 times 15.999, we end up with 47.997. We now add these 3 together, ladies and gentlemen. Did someone get a total for this? Adeline, what'd you get? I'm sorry, I missed that. 7 what?
3.
Point.
888.
What unit would we put with it? No, grams. When we're doing this calculation, ladies and gentlemen, these are always in grams. Questions? All right. Now, I do have a worksheet with this where you can practice, but before we do that, ladies and gentlemen, I want to get through a little bit more in the notes. All right. So, just a quick review. Atoms combine. Why do atoms combine? They combine to become stable. They can become stable by filling their valence shell. Their valence shell is their outermost shell. And they can do it 3 ways. What are the 3 ways an atom can fill its valence shell? Gaining, losing, and sharing electrons. 8 electrons fill the outer shell. The exception would be the first shell, which only needs 2. Okay? And we fill our outer shell or energy level by gaining, losing, or sharing electrons. Up until now, we have been talking about gaining and losing. When we were doing the chemical craps in the back, when we were writing our compounds in the last unit, they were created by 2 atoms, one that would gain electrons, one that would lose electrons. Metals would always lose, nonmetals would always gain. They were then attracted to each other because of opposite charges. Now, ladies and gentlemen, we are going to talk about compounds that share electrons. Compounds that instead of gaining or losing, they share electrons between the 2 of them. Okay? Now, gaining and losing electrons was an ionic bond between a metal and a nonmetal. Sharing electrons is what is called a covalent bond, and it is between two or more nonmetals, ladies and gentlemen. Two or more nonmetals. Now, how does this fit into what we are talking about with resources and fossil fuel and crude oils and things like that? That is because crude oil, fossil fuel, petroleum, gasoline is a covalent compound. It is two nonmetals bonded together, ladies and gentlemen. Two nonmetals bonded together. Now, the two nonmetals create what is called a hydrocarbon. What is in a hydrocarbon, ladies and gentlemen? Based on the name of it, what's in it? What? And carbon. Now, that is a good guess of water because normally hydro means water. But in a hydrocarbon, it is a compound that literally only contains two elements, carbon and hydrogen. Thank you very much. Okay. Now, the compound is made up of hydrogen and carbon. Any compound that contains carbon, ladies and gentlemen, is classified as an organic compound. You and I are organic beings. Every living thing on this planet is an organic substance. Plants, insects, animals, blue-green algae are all organic species. They all contain carbon. You and I, made of carbon. So they say that carbon is the basis for life on this planet. There are a few reasons for this, ladies and gentlemen. And part of it has to do where carbon is located on the periodic table. Carbon is in a very unique spot on the periodic table, ladies and gentlemen, because first of all, carbon is a nonmetal. Nonmetals can be involved in any type of bond, ionic or covalent. Metals cannot be involved in a covalent bond. Okay? It's also in group 14. Well, the thing about group 14, ladies and gentlemen, is that in group 14 and being a nonmetal, carbon has how many valence electrons? How many valence electrons would carbon have? Well, that's how many total electrons it has. How many of those electrons would go in the first energy level?
2.
So how many does that leave for the second?
4.
4.
I knew it.
Now, that is very unique for carbon, ladies and gentlemen. Having 4 valence electrons means it can do something that almost no other element can on the periodic table, ladies and gentlemen. It can form 4 bonds sharing electrons. Because it has 4 valence electrons, it has 4 electrons that it can share. Okay? So carbon can form 4 bonds. That is the most that any one element can make. There is no element on the periodic table that can make more than 4 bonds. Why? Because you have to have something if you are going to share with someone else. So if you are going to share with someone, you have to have something to give. They have to have something to give. Carbon has 4 electrons that it can share. That is the most of any atom on the periodic table. And carbon, because of that, because it's a nonmetal, it can bond with any other element on the periodic table. It can bond with metals. It can bond with nonmetals. It can even bond with itself, ladies and gentlemen. So when we pull it out of the ground, ladies and gentlemen, bless you, we pull out what is called crude oil. Crude oil is a mixture of all kinds of things. Now, mixture, meaning it can be separated how?
Nuclear by man.
What?
By man.
Can be separated physically. That's the important thing. Remember last unit we talked about an element, a compound, a homogeneous, and a heterogeneous mixture? Mixtures can be separated. You could pick things out. You could separate them. That is what petroleum that comes out of the ground is. It is a mixture of many, many things. And then we could separate them. That's why it is called crude oil to begin with, because it is a mixture of all these things. Now, the other thing that is in a hydrocarbon is hydrogen. Hydrogen is a group 1 nonmetal, but remember what was unique about hydrogen? It could act like a metal, right? So hydrogen could act like a metal, it could act like a nonmetal. Here's the other thing that's unique about hydrogen. How many electrons does it have?
1.
1. Now, because hydrogen is in the first level, the first period of the periodic table, how many electrons does it need to be filled? How many does the first level need? Total.
Over 2.
Needs 2. First level needs 2. Well, hydrogen has 1, which means it's how full? Half. It's half full. Now, that makes it kind of special. Actually, that makes it a lot like carbon. Carbon is half full as well. Okay? The difference is with only 1 valence electron, hydrogen can only make 1 bond. It can only form 1 bond. Okay? So carbon is the central part of these compounds. Hydrogen is around the outside. Okay? Hydrogen, like carbon, can bond with a lot of other atoms. It can bond with nonmetals by acting like a metal. It can bond with nonmetals by acting like a nonmetal. So just like carbon, it can bond with almost any element on the periodic table, ladies and gentlemen. Just about any one. And it can bond with carbon atoms. Anyone need more time with this slide? Okay. Now, not only can carbon bond with itself, ladies and gentlemen, it can actually bond with itself in 3 different ways. 2 carbon atoms can share 1 pair of electrons. 1 carbon gives an electron, the other gives an electron. That's a shared pair of electrons. That is called a chemical bond. And yet each carbon atom still has 3 other electrons to share with other elements. When carbon bonds with another carbon, bless you, and they each donate 1 electron to the pair, it is called a single bond. And the hydrocarbon name for a single bond between 2 carbons is an alkane. 1 pair of electrons shared between 2 carbons. Now, a lot of times we show it as a line. That line represents a bond. But what that bond really is these 2 electrons here that are shared between those 2 atoms. That are shared between those 2 atoms. Now, if needed to, carbon could share 2 electrons with another carbon. And it could share 2 pairs. We call that a double bond or an alkene. Okay? So that is a double bond or an alkene. And you would literally share 2 electrons from each carbon between the 2 carbons. Now, there is even such a thing as a triple bond, ladies and gentlemen. 2 carbon atoms sharing 3 pairs of electrons. 6 total electrons between them. This is called an alkyne. Okay? And yet, each of these carbons still on the ends here, this one could bond to 3 other things. This one could bond to 2 other things. This one could still bond to 1 other thing, ladies and gentlemen. And that makes carbon very unique, carbon very flexible. Questions? Okay. Now, this is just showing you something. Remember when we talked about valence electrons? And the valence electrons led to a charge on an atom. If you lose 1 valence electron, you're a +1. If you lose 2, you're a +2. If you lose 3, you're a +3. Well, it can also be shown as dots around the atom, and those dots represent those valence electrons. How many electrons are in the outermost ring? And if you're not going to gain or lose electrons, you are going to share electrons. And when you share, that is another way that these atoms can share electrons between each other and make compounds. Okay? And make compounds. So this is called a dot diagram, and it's showing the 8 electrons around the noble gases. This shows the 7 electrons around the halogen family, the 6 electrons around the oxygen, the 5 electrons around nitrogen. Okay? We will not have a lot of time to get into this, ladies and gentlemen, but I just wanted to show that to you. We're going to skip this. We're going to skip this for now. We're going to definitely skip that. Take a look at this list, ladies and gentlemen. You see anything on there that you recognize on slide number 25? What? What's methane? It is a gas. Anybody know where methane gas comes from?
Cows.
What?
Cows.
You bet. Actually, you know what else methane gas comes from? You. Yep, if you fart, you produce methane gas. Which is why, ladies and gentlemen, do not attempt it. But you can burn a fart. The gas that comes out when you fart is flammable. I don't recommend you trying it. Now, if you belch, that gas is not flammable. That's not methane. What else on that list do you recognize? Propane. Where do you use propane? Close. Think about it. It does come in a tank like an oxygen tank, but where do most of you have propane at home?
Grills.
The grill outside. Your grill outside. Most people have propane grills. Perhaps you have a propane torch in your garage for heating things up. Any others in here that are familiar to you?
Butane.
Butane. What's butane in?
Lighters.
Butane is the liquid that is in a lighter.
Yeah.
A disposable lighter that you can get at a service station, at a mini mart. That's butane. Any others?
I feel like I heard of ethane. I think.
Yeah, probably not. But there is one more that you might have heard of in this list. Nope, not decane.
Octane?
Anybody know where octane comes from?
Gas.
You got it. Gasoline. There is an octane rating between regular unleaded, super unleaded, and that. Super unleaded, the really expensive stuff, has a lot more octane in it. Why would you put super expensive gas in your car? You wouldn't, unless you happen to be driving a really nice sports car. If you were driving a Corvette, if you were driving certain models of Mustangs, certain models of Dodge Chargers, they require you to run super unleaded gas in them. Why? They need a higher octane rating for the engine to run in its proper way. Because the gas creates more power for the car. Okay? But what do you notice about all of the names?
They end with A's.
They're all A's. These are, and look at the formulas. Only two different elements in here. Carbon and hydrogen. Right? Carbon and hydrogen. Now, I admit the first four names don't always make the most sense, but look at 5 through 10. Look at the name of 5 through 10. Where did the name come from?
Shape.
Kind of. You're close. Not the shape. Because we can't really see the shape of these, can we? But they are shapes, right? Pent, hex, octa, hept. Anybody know what hex means?
6.
6. What does pent mean?
5.
Look at the formula for pentane. How many carbons? There's 5 for pentane. How many for hexane? How many for decane? Like deca means 10. Octa means 8. So after the first 4, they are named based on the amount of carbons in them. Based on the amount of carbons in them. Okay? Now, we won't get into molecular and empirical formulas. We will not have time, ladies and gentlemen. Okay? But one of the things, okay, about alkanes is they are all hydrocarbons and they all have single bonds, ladies and gentlemen. Every bond in the compound is a single bond. Now, hydrogen can only make single bonds. Carbon can make double and triple. Alkanes, all single bonds. All carbons singly bonded together. And by the way, what this means is it's holding the maximum amount of hydrogens. Can someone tell me the term, the prefix for holding the maximum? When something is holding the maximum, what term did we introduce in the last, or in 2 units ago, for something holding the maximum? Nope, you're close. Yeah. Okay, saturated, unsaturated, supersaturated. Which one is holding the max? Saturated. Super is above the max. Even more than the max. Okay? A carbon that is, or a alkane that is holding the maximum amount of hydrogens is said to be saturated. Next trimester, ladies and gentlemen, when we talk about fats, we will talk about saturated fats. We will talk about unsaturated fats. Okay? So that is coming up. By the way, every alkane has a general formula. CnH2n plus 2. If you know the number of carbons, you can find the number of hydrogens. It is always the same in an alkane. And by the way, these alkanes can get really big. They can be as small as 1 carbon. They can be as big as hundreds of carbons in the compound. Hundreds of carbons connected together, making a compound, ladies and gentlemen. Questions? So what if you have 16 carbons? How many hydrogens will you have? Well, do 16 times 2.
32.
And add 2. 34. So if you have 16 carbons, you are going to have 34 hydrogens. You can find the formula of any alkane if you know how many carbons are in it. Any alkane. Okay? So if you had 21 carbons in it, how many hydrogens would you have?
44.
You would have 44. Thank you. Thank you. Tomorrow we will talk about distillation and viscosity, ladies and gentlemen. Please come up and put the calculators back for me. If you want to log out, I will return that for you.
That is the molar masses, which are the numbers that are underneath, or not underneath, but the decimal numbers for each of those things on the periodic table. So up here, these are all the exact same amount of things up here. These are all 1 mole of something. But for carbon, its mass is 63.55 grams because that's what it is on the periodic table. For aluminum, it's 26.98. Whatever the mass is on our periodic table, that is how much there is when you have 1 mole of something. Okay? 1 mole of something. And all of these things have the exact same amount of pieces here. It's kind of like saying you have a dozen basketballs and a dozen volleyballs. You have the same amount. Are they the same size? Are they the same mass? So none of these are the same mass, none of these are the same size, but what is the same is they are the same amounts. Okay? They are the same amounts. Lead is a very dense material, yes. Mercury is even more so. Mercury is about 13.6 grams per ounce or per cubic centimeter.
Imagine getting 1 mole of water a day.
You get more than that.
I said imagine like whatever has a reaction.
Oh,
That's all you got.
you wouldn't survive. You would not survive. Okay, but think about this. Hold that, Christian. That's 1 gram per cubic centimeter. Mercury would be 13.6 times that. 13.6 times heavier than that.
Same as bread.
It is. It's very dense.
You marked me late.
Well, you were late.
I had a pass.
Okay, then I'll go back and I'll change it.
Pass is in the garbage over there.
Whoa.
A good one.
You betcha. Thank you.
Ariana Dubois and Zachary Phillips, please report to student services.
Have a seat wherever you'd like. Okay. So, you need to do these 5 formulas and these 5 names. Then you need to do the 10 inside on each page, like you did on the test.
Okay.
Only do 10. B or T for binary or ternary, IA or C for ionic covalent or acid. And then you just need to answer those few questions. Okay? If you need any help, well, I will help you what I can, but if you have any questions, let me know. Okay?
Okay.
Does music bother you?
No, I don't mind.
You sure? Because otherwise I won't play any.
No, it's fine.
Okay. Will my music bother you?
I don't think so.
Okay, good.